All right, so we've already been looking at graphs with functions with tables and mappings and the actual graphs, right? And you can see up there at the top, it talked about we made U-shaped graphs, V-shaped graphs, and lines. So, but now we're going to tie together the idea of a function and a graph that makes a line. So we're going to be looking at linear functions. And so if you graph a linear function, it's just a straight line, that's all. So that's the first blank there. So it's a straight line. And it says, what is the only, below that it says, what is the only line that is not a function? Well, we said in our definition of a function, for each x, there has to be exactly one y, right? And so when we were looking at the graphs, you could not have one point directly above or below another point, right? So that means a vertical line would be the only line that's not a function. So that second blank there is vertical line. And Ryan, you need to put that phone away or it's going to go in the jail till after school. All right, now I never really talked about this. There's a test you can use to decide whether it's a function also. So off on the side here, I'm going to draw a little picture for you guys. So like if you had, let's say you had a graph like this. Was that one a function? You don't have to graph this part if you don't want to. Is that a function?
No.
No, because there's a point that's directly above or below another point, right? Well, what you can do is you can do something called the vertical line test. So if I draw a line anywhere on that graph, if I hit more than one point, then it's not a function. And the reason would be is because, like, let's say this was the point. Let me draw a little table for this one. So if I do a little table for this, and again, you don't have to write all this part down if you don't want to. Can you see that the point 3, 2 would be on that graph? And the point 3, -2 would also be on that graph. Do you see that you got a repeating x value? That tells you it's not a function, right? If I did it as a little mapping really quick, so I'd have, no, I wouldn't have that. What was that? So if I did a little mapping for this one, this is the domain, that's the range. 3 would map to 2. There's no coughing during recording. And 3 would map to -2. So right there, there's 3 different ways you can see that that's not a function. And that should help you out on today's test also. All right, but anyway, so what I was talking about was this vertical line test. We know from before that you cannot have a point directly above or below another point. Well, then you can use this vertical line test. So let me write that down, what that is, so you have it. So we're going to say it's not a function if it fails the vertical line test. I guess I could write out a definition of what the vertical line test is below that for you guys. That's actually, I don't even think that's in your book. What you want to write is, so if you would draw a vertical line anywhere on the graph, so if you draw a vertical line anywhere on the graph and you hit more than one point, I'm going to run out of room here. And if you hit more than 1 point, then it's not a function. All right, so hopefully you guys can read that. It's pretty small. All right, so what it says right there, if you can't, yeah, it's pretty tough to read that. It says if you draw a vertical line and you hit more than 1 point, then it's not a function. All right, so look at example 1 there then. Is that a function? Yeah, because if I draw a vertical line anywhere on there, I only hit 1 point, right? Is it linear? Yeah, because it's a straight line. So you want to say yes and yes. So yes, it's a function. And yes, it's linear. All right, now look at the second one. Is that a function? If I draw a vertical line anywhere, I hit just 1 point, right? So yes, it's a function, but is it linear? Yeah, it's not a straight line. So this one is yes and no. So it's yes, it's a function. But it's not linear. All right, so that's that one. And then the next one, well, we just talked about this. What's the only line that's not a function? A vertical line, right? If you draw a vertical line on a vertical line, you're definitely hitting more than 1 point, right? You're hitting a whole bunch of points. So this one's, this one is a line, but it's not a function. So it's a line, but not a function. Yeah. Well, it's not it's linear, but it's not a linear function, you know. And why do we like functions? Yeah. Yes. Because the fun is already built in there, right? They're functions.
That was kind of fun.
All right. Let's keep going. All right, I already reviewed some of this with you guys earlier. So this says, how can you tell from a table of ordered pairs whether it's a function or not? So functions have no repeating what? Yes. So no repeating x values. Or domain values, right? The domain is the same thing as the x values. And if it's linear, there's going to be a constant change in the x values and also a constant change in the y values. So this is going to be x values.
How is that statement true?
What's that?
How is that statement true?
How is that statement true?
Number 3, they're both standing on like.
Hold on, we'll get there. And then, so you got to have in order to be a function, or let me say this. So in order to be a function, for each, I can't talk now. In order to be a function, for each x value, there's only one y value. So you can't have any repeating x values. And then if it's going to be a linear function, there has to be a constant change in x and a constant change in the y values. So this should say y values right here. All right, so hopefully you guys can read that. All right, so let's look at these next two problems. So number 4. First of all, well, they want to know right away, is it a linear function? Is there a constant change in the x values?
Yes.
Yes. What is it?
4.
Yeah. The x values are all going up by 4, right? So to get from here to here, you got to go up 4 each time, right? So it's up 4. What about the y values? Is there a constant change in the y values?
Yeah, going up by 3.
Yeah, good. Yeah, these are going up by 3 each time, right? So then you have both. You have a constant change in the x values and you have a constant change in the y values. So yes, it's a linear function. All right, what about the next one?
It's not a function.
Now, are the x's changing by the same amount?
Yeah,
What are they doing?
they're going up by 2.
Yeah. So the x values are changing by 2. So you're adding 2 each time. But what about the y values? Let's see, to get from here to here, you're going, what, down 12? And then to get from here to here, you're going down 4. So does everybody see you don't have a constant change in the y values? Now, it can still be a function, right? Are any of the x values repeated?
I don't think so.
No, you have no repeated x values. So it's still a function. It's just not a linear function. To get the linear part, you need the constant change in x and the constant change in y. And so for this one, you only have the constant change in x. So this is not a linear function. Again, you guys got to realize it could still be a function, it's just not linear. All right, and then we got to fill all this stuff in. All right, this blank here says we've looked at graphs, relations, we've looked at mappings, we've looked at functions, we've talked about what it means to be linear. Now we're going to look at linear equations. All right, and then the standard form for a linear equation, it's going to be capital A times x plus capital B times y, and that's to equal capital C. Now, in the rules there, what are the exponents on the x and the y there? What power are they raised to? What's that?
1.
Yeah. So if that's a first power and a first power, then you know that it's a linear equation. So both exponents have to be 1. All right, then also x and y cannot be multiplied together. So in other words, I'm going to write some examples on the bottom of the screen here. You don't have to write these down. So it can't be like, you can't have like 3xy equals 5. Okay, that's not a linear function, or that's not a linear equation, because you've got x and y multiplied together. So x and y cannot be multiplied. All right, then the next one. It says x and y are not in the, well, they can't be in the bottom of a fraction, so they can't be in the denominator. And again, I'll write an example on the bottom real quick. So you can't have something like, and you don't have to write these if you don't want to, you can't have like 3 over x plus y equals 10. All right, that's no good. That would not be a linear equation. And then x and y cannot be in a radical. And a radical is like a square root or a cube root or something like that. So you can't have the square root of x plus y equals 2. That's not a linear equation. And then or, the last one is x and or y cannot be in the exponent. So that would look something like if you had something like 3 to the x power plus y equals 5. So that one's not a linear equation, neither is that one. All right, so let me erase these out of here. So then the next couple blanks there, a, b, and c in that standard form up there at the top, the ax plus by equals c, they have to be real numbers. And a and b cannot both be 0. A could be 0 or b could be 0, but they can't both be 0. All right, then let's look at the ones they have it down there at the bottom.
What's the one with the right and radical thing?
Exponent. All right, let's look at this first one here, number 6. So you're using all these rules that we wrote above to decide whether this thing is a linear equation. So what do you think about 6? Does that look like a linear equation?
No, yeah,
Are x and y both to the first power?
no.
Yeah.
Yeah, they are, aren't they? That's x to the first, that's y to the first, right? So I think we're okay. So then that one, yes, that's a linear equation. Now, they also want us to, it says over here to the right, they want us to put the equation into standard form if it's a linear equation. So we got to somehow write it in this form, that ax plus by equals c. So what you would do with this one is maybe like subtract 2y on both sides. So subtract 2y on the right-hand side and then subtract 2y on the left-hand side. And you'd then have, you'd have 1x minus 2y equals a positive 4. Those two y's would cancel out right there. So you can see that's in standard form. I guess I could do this for you guys. I guess I could write it as, just to really make it match, I could say 1x plus negative 2y equals 4. And then you can see it fits that form. It's in that form, ax plus by equals c. C is just some number, okay? It's a constant. So again, we're trying to put it in this form right here. Okay, so then, and in that, if I did that in that case, then hopefully you guys can see then capital A would be 1, capital B would be negative 2, and capital C would be 4. What about the next one? Well, and also I forgot, we were supposed to write linear, this is a linear equation. So yes, it's a linear equation. I'll just abbreviate equation as EQ. All right, what about 7? No, because it violates that second rule, right? You can't have a term that's x times y. So this one's not a linear equation. Not a linear. All right, what about the next one? No. This was because you had the x and y multiplied together. What's wrong with number 8?
They're to the power 2.
Yeah, these exponents on x and y have to be 1, right? Or even if x had the second power or y had the second power, your answer would be no, it's not linear. So this one's not a linear equation either. All right, and then number 9. We got 2 more to go. What about 9? That one okay? Well, you could add y on both sides.
Oh.
And then these would cancel out, yep, and then you'd get,
Oh, so it is.
yeah, you get 5x plus 1y equals what? What do I got on the left-hand side? What's negative y plus y?
0.
That's a 0. So that works. Because then you'd have capital A would be 5, capital B would be 1, and capital C would be 0. So yes, that's a linear equation. All right, what about 10? No, what's wrong with it?
Y in the denominator.
Yep. You can't have x or y in the denominator. So this one's not a linear equation. We're just about done.
What did you get for 8?
8 was the powers on x and y both have to be a 1, so it's no. All right, so we got to flip it, right? All right, we're on page 2. So we're going to do a couple graphs here real quick, and then we got to get going on the test. So this is the same. This is going to help you out for today's test. We got to do some graphing on there, right, for chapter 4. So to graph a linear equation, we're going to just plug in x values, right? It says we're going to plug in domain values. And in this case, they don't give us a domain, so we get to plug in whatever real numbers we want for x. And we'll make a little table. But I want to make a note here. It says use the domain there, that blank. We want to use 3 x values. And the reason is you don't have to draw this if you don't want to. If I only use 2 x values, if I get 2 points, well, I can always draw a straight line through 2 points, right? You want to do 3 points in case you get something like this. If you get 1 point here and 1 point here and then 1 point there, what do you know you did? What's that? Yep, Damien, that's good. Yes, you messed up, right? That's why you want to do 3 points. Because, you could draw, if you only did these first 2 points, you could draw a straight line through those 2, right? But you can't draw a straight line through all 3 of them. So you want to make sure by doing 3 points, if you do 3 points, you want 1 point to line up with the next point. And then you want to do that 3rd point to check to make sure maybe the 3rd point ends up over here. Well, then you can see, yeah, you did it right because they all line up, right? They line up in a straight line. And of course, I told you if you miss, you just make the point larger. And by the way, you guys, I have rulers over here on this table. So when you're drawing these things, use a ruler, all right? I'm getting graphs that turn into me that look like this. All right, that's a straight line, You guys can do better than that. All right, so let's do these 2 real quick. So we want to use the domain with 3 x values. We'll put with 3 x values here. All right, and then we just plot the points and we connect them and then we put arrows on them, we're done. So we're going to graph this first one. So the trick here is to figure out what you should use for x, right? Your domain is all real numbers, so you can use whatever x values you want. We're going to use 3 of them. Well, for example, do we want to use 1 for x? Like, what do we get if we plug 1 in right here? 5 times 1 plus 9, what's that?
14.
14. Does 14 fit on the grid? No, it does not fit on the grid. So then you probably don't want to use 1. What should we use?
-1.
-1 would work nice. Rachel, thank you. That's a good one. I like -1. Because now I'm going to take -1 and I'm going to plug it in right there for the x, right? What's 5 times -1? -5 plus 9? That's 4. Well, that's going to fit on the grid, right? All right, and then anybody got another one? Yeah, 0 would be good. I like that. 0, 5 times 0 is 0. 0 plus 9? 9. And then another one. Well, we don't want to do positive 2, right? Because that's going to give us 10 plus 9 is 19. Negative 2, yeah. Negative 2 would be good. So if you plug in negative 2, what's 5 times negative 2? Negative 10 plus 9. Negative 1. All right, there you go. Now, if we plot these, they should line up in a straight line. If they don't, we messed it up, right? So here we go. Negative 1, 4. So we got to go 1 left, 4 up.
Okay, see the lines.
I know, it's hard. And then 0, 9. So that's 0 left or right and 9 up. That's up here. And then negative 2, negative 1. That's 2 left, 1 down.
That looks like a straight line.
There you go. So they line up so you know you did it right.
I actually.
You connect them and put arrows on the end. Now the next one's kind of weird. This is the last one. So this one, we're still going to make a chart here. This is still a good way to do this. So we're going to do 3 points. But it says y equals 6. Remember back when we were talking about that standard form, it said, remember standard form was ax plus by equals c, right? Well, this one still conforms to that, doesn't it? Just the a happens to be 0. All right, the a is 0, so you got an equation that looks like by equals c. So what you really got is an equation that looks like 1y equals c, right? You guys see that or no?
Yeah.
So capital B would be 1. Capital C would be 6. Capital A would be 0. All right. But anyways, to get back to this, if you just got 1y equals 6, well then the y value is always 6.
So it's a horizontal line.
Yeah. Yep. If y equals 6, the y value is always 6. Doesn't matter what the x values are, right? The x values could be any real number. Give me 3 x values.
1, 2, and 3.
1, 2, 3. Let's plot those points. So 1, 6. 1 to the right, 6 up. That's here. Actually, I'll do that in the other color. So we got 1, 6. And then we got 2, 6. And then we got 3, 6. Can you see that we got a horizontal line?
Yes. Added in on the table.
Is that a function?
Yeah.
Yeah. Good, Ryan. That's good. Yeah, that's a function. If I draw a vertical line